Well, good afternoon. I don't know if there's anybody here. I don't think there is. I'm all by myself. That's fine. We don't need anybody. Let's go. So assignment 3. So this one and assignment 4 go together. And what we have is data that someone scraped. It's a term that's used of stealing stuff off the internet, that they scrape it, they say. I guess they use Python to do that. It's a popular method. Anyway, it's got a lot of different variables about automobiles, about 2,500 different cars. And that's the original data set. But what I've done is I've excluded quite a few. There were a lot that had missing data on some vehicle characteristics, which is mess us up because we can't deal with blanks when we're doing multiple regression. And we also had, oops, okay, more coming in, okay. There are also a lot of really custom, unique vehicles that are in the data set. And these are like handmade European Maseratis and Bugattis and Bentleys, you name it, super expensive cars, like cost several $1,000,000 for just a single vehicle. And I figured they probably would give us some difficulties. So I've taken them out as well and got us down to a group of 1,008 vehicles. That's still quite a lot. In the data set, we had data on miles per gallon city and miles per gallon highway. And if I'm looking at fuel efficiency, I just did the simple thing of averaging those two. And this is American data. So they're talking of distances in miles and per gallon, US gallon of gasoline. And some of the dimensions, I think, are also in inches. That there is a little bit, I think, that might be in metric, but don't worry about it. It's just data. Okay, so the first thing I've suggested we do is just try to get a sense of the variable we're studying, which is the miles per gallon, and to look at it with both a box and whisker chart and a histogram. Okay, so those should be ones that you've done before and you shouldn't have difficulty with. But just to remind you, how do we do these sorts of things? So this is the last column over here, column W, average miles per gallon. Okay, and I'm going to take that one, and if I want to do it, let me get this out of my way here. So I've got too many controls showing up. Go to insert, and the first one I suggested we do is just a box and whisker. So we can go to that box and whisker and click on that, and we should get a chart like this. So if you're looking at this, it's half my data is in that blue box, which is from about 20 miles per gallon to about 27 or 28. And then we've got some that get much better mileage. So bigger numbers are better. You get more mileage. And some that are lower, down to about 12 or 13. And then we have a small group of outliers. We generally are looking at shape, so it isn't unusual to go and look at histograms as well. And so you could do that. Again, taking that same one, I could go to insert, and I can go and ask for a histogram instead. Okay. Oh, where'd it go? There it is. And you can see it's sort of skewed in terms of the data. So yeah, so I've asked you here, I'm not making you do anything fancy to this, no labeling on it, no fancy charts, not editing it in terms of the scale and that type of thing. So you see, this is where most of the vehicles are, okay? And sort of bulge, and then we get this long tail to the right. We've got some that get crazy good mileage, really lumpy looking. It's not any bell shape by any means. So I've asked you to take copy a picture of these sorts of things and paste them into your assignment. Did I ask for about? Yeah. Remember how to do that. Just to go back to that again. If I want to take a picture of this, if you're on a Windows machine, you press the Windows key, the Shift key, the S key. Screen goes dark. Take that little cursor, highlight the piece you want, let go. It's now in your clipboard. Go back here, and so right here, if I'm pasting this in, I just paste it. Boom, that's it. Okay, I don't want a picture that looks like this whole screen that I've got here with a little chart in the middle, because there's all that waste space. I just want the chart. So and you can express what you think about that pattern that's there. Now, we're going to look at starting to build a model at this stage. These controls in here. And suggested that probably of the variables that I've got here, and I've got quite a few, the things that are going to affect fuel economy are probably the weight of the vehicle, but I don't have that. But I do have its length, width, height, that type of thing. So length might be a good proxy to give me an idea of the size of the vehicle. And also the size of the engine. You know, usually fuel efficient cars have really small engines, and gas guzzlers are ones with great big engines. So we can go and look at that as well. So let's look at those in scatter charts. Now I've suggested with this, because we're going to be doing a lot of things, to go and create separate tabs in your spreadsheet for these different things. So I'm going to be looking at, what did I pick? Displacement, I think. Displacement, it's measured in liters. It's total volume of the combustion chamber in the vehicle. These are gasoline-powered vehicles. There's no electric ones here, obviously. So I've got that, and I want the length of the vehicle, and I want average miles per gallon. So I'm going to copy these and put them in a new sheet. I just hit the plus sign to get a new sheet, paste them all in here. And there's too much clutter here. And so I'd like to go and look at how these two variables affect miles per gallon. I've got miles per gallon on the right, so it's going to be on my vertical axis, and I'm going to do two charts, one for each of these two variables on the horizontal. So if I want to do one with displacement, I can pick displacement, average miles per gallon, go to insert. I'm going to go to charts. I'm going to pick a scatter chart. And there I go. I think I've got the right things here. So displacement on, and now I'd like you to label things. So here on what I'm going to do, I'm in the chart. I'm in design in my chart. And, excuse me, I can add chart elements. Go to add chart elements. I want axis titles. On the horizontal, there it is. It just popped it up. And I'll type in displacement. And it should now appear there. Okay, so displacement here at the bottom of my chart. And I'm going to go, I'm still in my chart. I've got to click on it, get these menu things, design. I'm going to go to add chart element, axis titles on the vertical. I'm going to put in average, miles per gallon. I think I typed that correctly. It's a matter of preference. Personally, I would right click on this, but you don't have to. And I can go to format axis title. Thing over here on the right. And the third box here, size and properties, I can click on text direction, and I like everything to be horizontal, just a matter of preference. Okay, and then give it a title. Don't just say average miles per gallon. What are you looking at in this picture? And it looks like average fuel economy, or you could write miles per gallon decreases with let me just say this. I could say decreases with increasing displacement, or decreases for big engines. That I drive a Subaru SUV, a Forester, and it's got a displacement of about 2.5 liters. So it's not that. So imagine what your vehicle would have to be to have a displacement of over 7 liters. Probably a big truck. But it's a big vehicle for sure. And there are actually some cars, Bentleys and the like, that have huge, huge engines in them. Anyway, copy a picture of that. So I want it to have the axes labeled, a title on that, copy it in, do the same thing again, but this time with the length of the vehicle. And then comment on what you've seen there. So as I said, I want it to have an informative title. So there does seem to be a pattern, and you'll see one with length, but there's also a pattern. And that generally anything that makes your vehicle bigger reduces your fuel economy. And that we're going to find most of our variables here are negatively correlated with fuel economy. So what I'd like you to do is take all of the numeric variables and make a correlation table with that. How do you do that? Let's go back to our data. So what was this? Was this question 1? Question 2? I think it was question 2. So I know what to go back to. And I think I'm into question 3 now. So I've got variables here, a whole bunch that had words and these sorts of things. And this one here tells me about engine type and the like. And this is actually telling me the displacement as well. But numeric ones start with price. Let's get this out of my way. Notice how these charts have just cluttered up my work. I should really have taken that average miles per gallon, put it in a new sheet, made up a chart just to deal with question 1. So let me take all of these guys out, copying them all, put them into a new sheet. And so that it didn't copy my chart over. So I'd like to find how they're all interrelated with average miles per gallon. So if I go to data and I go to data analysis, I want correlation. Now I've got a whole bunch of other things in here with stuff I was doing on this. So this is from A1, that's the top left corner where it says price, put a colon, and the last column is column N, and the last row is row 1009. It's worth remembering it so you don't have to scroll through it. I've got labels in my first row, so I check that box off. And you can put it into a new worksheet, but we're going to have a lot of worksheets. And this is one I'm just having for correlation, so I'm going to put it in the same one. So I can click on output range instead of new worksheet, and I'll put it in P1. So right up here. Click OK. Boom, big table, lots of tiny numbers here. And we're looking at average miles per gallon. So for the moment, we're not going to look up at here. We can look at who are the big ones across the bottom here. Don't worry about the minus sign. So it's this absolute size of this. And you'll get some of them over here. Miles per gallon city is 0.97. Miles per gallon for highway is 0.97. Remember, we averaged those two figures to get the average. So obviously, they're going to have very, very high correlation. But I can't use this to help me predict the fuel economy of the vehicle. So first off, I'd like you to pick out which are the 4 that are the biggest. So just look in absolute terms. And then suppose you grab some. Let's just look at a couple that are big. Like here 2, they're both big. One's called power, one's called displacement. Okay. I'm not expecting you to understand the physics of an internal combustion engine, but is there any reason to be concerned about using both power and displacement in my model? And there'll be 2 others that you're going to be using as well. You're going to find that they're all together. Are there issues about using them all at the same time? Okay, and I don't care if you understand that the displacement is depends upon the number of cylinders, and that the horsepower, the power of a vehicle, is, generally depends upon the displacement, and the torque of a vehicle depends upon power of the vehicle. So there's a whole bunch of those things. And similarly, like if you are looking at length, width, height, generally longer vehicles are also wider. They're probably trucks. Oh, trucks are taller as well. So again, we'll probably have interrelationships among variables when you get bunches of them. Anyway, giving away the answer. So you should find that torque is the one that comes out as being the strongest. Okay, and so we're going to build a model that involves torque. Okay. First off, do a scatter chart of that, okay, and paste it in your assignment. You'll see the relationship between torque and the average miles per gallon. It's like we did in the first question, or second question. Now I'd like you to build a model, though, that uses the torque to predict average miles per gallon. So let's go back here to our data. Go to our assignment here. So I'm going to be using torque, which is a rotational force, I guess is one way of describing it. And average miles per gallon, I'm going to copy the 2 of them, put them in a new sheet. Okay. And do a scatter chart on them. And I've got torque on the left, average miles per gallon on the right, so it should give me a nice chart. And I want to build a regression model. So this is easy to do. You just go to regression, click OK. And now I've been playing with models this morning to make up your assignment 4. So where is my y variable? The y variable is the one you're trying to predict. It's the one on the vertical axis. And so that's in column B, B1, B1009. And the x variable is the ones that you're using to predict. So the ones would normally be on the horizontal axis. And that's in column A, A1 to A1009. I've got labels. And I generally recommend that you keep labels when you're doing this. It makes your output easier to look at. The default is to put it in a new worksheet, but I keep everything together when I'm playing with models, and I try to pick a location that's close to where I was working. So like D1, I know it's moved around here, D1. So something up over here, okay? Ask for residuals and residual plots. So we may be using some of that. And then click OK. Okay. Gives me one plot because I've got one x variable. If I was using several x variables, it'll give me more plots. In assignment 4, you're going to have lots and lots of plots. You've got output. Here, I generally like to widen these columns here so that I can read what the headings are properly. And generally, we only look at the first 3 columns. We, in this course, will not be paying attention to things like t-stat, p-value, lower 95%, upper 95%, and so on, that they aren't necessary for what we're doing. In a statistics course, you would be using that, okay? So, and take a picture then of, I think that's what it asks for. So do that, fit that model, regress, copy the regression summary output into your assignment. So doing that, I would go and do Windows Shift S. And as I said, I don't need all the columns. At least give me these guys, okay? You can take some more if you want to, but I don't need the plot and I don't need all the residuals. Let's take that bunch and I'll put them here. That's all I need, okay? We aren't using the ANOVA table that's in the middle, but don't worry about that, okay? So the scanner shot. All right. I'd like you to go and try to explain this minus 0.03 in as simple language as you can without knowing what torque is. If you want the units for torque, it's measured in foot-pounds. It's a measure of force. The intercept generally doesn't mean anything in most regression models, but try your luck at trying to explain what it is for this particular model. That and use as simple language as you can, okay? That in the data set, I'm looking at question E, we've got two Honda Accords, and one of them's a Honda Accord Hybrid Sport with a torque of 247, and the other is a sedan coupe model with a torque of 260. So I want you to make predictions for both of those. Have an idea of how to do that. Okay, I haven't asked you to write out the model, but to be able to do this, okay, I've got to write out what my model is. My model in this thing is my estimated, everything comes out of a model as an estimate. It's of an average, and this is of miles per gallon. And it's always an average. It's where the line goes. Is supposed to be equal to, I have to scroll up here a little bit, 33.55 minus 0.03 times my torque. Okay, so it's a simple formula, is all that your model is here. Oops, excuse me. You just undo my last move here. Okay, so this is what you can see this is the model that's been created by Excel. And so what I'm asking you to do is just, you've got two cars, one with a torque of 247, one with a torque of 260, put them both into the equation that's there, and you're going to work out two predictions of average miles per gallon. And I'm asking, are the predictions any good? Now, let me just go back here to my original data here. You can look at it here. Here it is with the 247, 260, and here's their average miles per gallon. The first one got 42.5. The second one got 34. Huge difference. Both Honda Accords, that they're very, very similar torque. But as noted, the first one is a hybrid and the second one is not. So you shouldn't be surprised if the hybrid doesn't do better. Look at your predictions and look at those values and see, are they very good? Maybe it's okay for the hybrid, but it isn't for the other guy, or the hybrid, it gives an awful prediction for, and it's good for the other one, or maybe it's bad at both. That we don't know. Now, what I'd like you to do is we're going to explore it building a better model. So to do that, we have to look at these mistakes like the ones you just found here. So you're going to find with these two what the errors were in the predictions. And I want you to see how that's correlated with the other variables, see if we can improve them. So let me go back here. And if I scroll down on my sheet, see down here, it has the residuals. Take these ones, Shift, Control, down, copy them, okay? Make yourself a new sheet. Paste in my residuals. So those are all the mistakes I made. You can see these. And I want to see, well, how do they relate to the variables I haven't used? Because there are a lot of variables here, price all the way up to wheelbase. So let me put those in. Okay. Now, I'm not going to need torque. I've already used it. Okay, so you can get rid of it. All right. So these are the variables that are left. What's the relationship between them and the residuals? Can I use them to predict my mistakes? Go to data analysis, go back to correlation where we were before. Click OK. And where is my data? Well, it's in A1. And now my last column is K. And again, goes down to row 1001. I've got labels in the first row. I'm going to keep all my output together. I'll put it over here in M1. So right up here, just above. Click OK. And I get another table. Okay. So now watch it here in reading it. Remember last time I was looking at average miles per gallon, it was sitting in the bottom here, and I was looking at correlations with it. Now I'm looking at my residuals, and it was the first column. So it's this column here has the correlation between the residuals and the different variables. Okay. And you can look at power displacement cylinders, and those were actually ones that were quite good before. Are they still quite good? Power displacement, you're probably going to find they've changed quite a lot. You can comment about that. Now, height ends up having the highest correlation that's here. So I'm going to build a new model, average miles per gallon being based upon torque and height. Go back here, because I'm not predicting residuals. I'm going to use height. And that's because in this sheet I just had, I look down this column, displacement looks useful, cylinders, not as good as before. Seats, hey, that one's good. But height is at 0.38. It's the biggest number. So I'm going to grab it. Go back to your original data. I'm going to pick torque. I'm going to pick height and average miles per gallon. I'm going to copy them, put them in a new sheet. Okay. I'm going to build a new model. I'm going to go down here. I want regression analysis again. Okay. Watch what you've got here. This is from the last time you were doing stuff. So you've got to update these guys. So my Y variable is now in column C. And my X variable, that's in columns A to B. A1 to B1009. I got labels. I'm going to put my output on the same sheet. So I'm going to put it over here in E1. I'm going to get residuals and residual plots. Click OK. Okay. So here's my new model. It's got new plots. Okay. It's changed here. It was 33 before. Now it's 44. But torque was minus 0.03. Now it's 0.028. It's changed a little bit. Height it's now come in here as a variable as well. Okay. So you've built that, copy those tables like you did before, write out the new formula. So I showed you a formula before that just had the one variable torque in it. Write out the full formula based upon this. So you've got intercept plus minus 0.028 times the torque and minus 0.18 times the height. That's your formula. Write all of that out. Now, I'm asking you once again, try your best to give an explanation of the meaning of the height coefficient. You know what the variable is. It represents how tall the vehicle is, but what does the coefficient represent? Also, this time I've asked you to look at R squared and standard error. So go back, look at your output. You may see it's hard to read them. So widen these columns so you can see what's there. So there's information now on R square and on standard error. Tell me what they are. So do you think the model is better now than it was in the previous question, and explain why you think it would be better? And I'd like you to make new predictions based upon your new model for the Honda Hybrid and the Honda Accord. Or they're both two Honda Accords, but the hybrid and the one that was not a hybrid. So you'll need the numbers for those guys, but you've got that these are still the first two vehicles. They're both the same. They have exactly the same height. But see if you get better predictions than you had previously. I would hope so. And that's all I'm pushing you to do at the moment. That I know in class, we've talked about a lot of other issues like standard error of coefficients and other aspects of it. We'll hit you with that type of thing in assignment 4. But first, we want to make sure that you can go through the basics of building a model, finding residuals, looking at correlation with the residuals, building a second model, and being able to read that basic output. And that's all you're doing in this assignment. So that's it. So we're done, half an hour. I've just got the one. So I don't even know how to pronounce your name. Arlene? Healing? Spelling I don't recognize. But glad you were with me. Anyway, this is it, guys. Hopefully that helps you out. Let me end this session then. I just got to figure out how to do that. There we go. Oh, something in the chat. Okay, thank you. And I apologize for messing up your name. Take care.